All right, elite team. So we're going to go ahead and discuss our final topic that we're going to cover in this class in regards to matrices, and that is the reduced row echelon form. This can work for any rectangular matrix with a certain kind of dimension. However, in this class, we're going to only focus on 2 by 3 matrices. Now, an echelon formation is actually something that we see a lot in history and in military use, in particular in the world wars. The idea of an echelon formation is this diagonal formation. In a bigger matrix, a reduced row echelon formation will look something like this. So you'll note that what would kind of look like the main diagonal is all ones, and then everything else is zeros. We call this an upper triangular, lower triangular matrix, depending on how it's set up. And then in this last column, we would have all of these numbers. Okay, these question marks are going to be numbers. So in order to get a matrix into reduced row echelon form, we are allowed to play a game with 3 rules. The 3 rules are called row operations, and they involve us dealing with rows only. We don't do anything with the columns. When we are expressing a matrix in reduced row echelon form, we are only working on rows. So let me give you some examples of what this is. Our first rule is we can switch any 2 rows. And what this looks like is something like R1 switch with R2. Or we might want to switch R2 with R1. So this is pretty much like shorthand telling us what is happening here. So this is the first rule. It will be switching any 2 rows. And when we do that, we only switch 2 rows at a time. So for larger matrices, we wouldn't be switching multiple rows at the same time, only 2 at a time. Second rule of the game, we can multiply any row by a number, except for 0. We can multiply by fractions, by decimals. We can multiply by positive numbers and by negative numbers, just not 0. So for example, I could multiply, let's say, row 1, by a 2. And then whatever answer I get for that, I would put it back into row 1. Or I might multiply 1/3 to every element in row 2, for example, and then put it back into row 2. And this will make more sense as we show you examples with numbers. Our third rule with row operations is one of the more fancy rules, and this is one of the more useful rules, but we only use this when we need to get zeros out of something. So this would be multiply 1 row by something, add it to another row, and then replace it. So for example, if I have 2 rows and I want to multiply row 1 by everybody by 2, and then I add it to row 2, and I might put it back in place of row 1. So that's an example of what it would look like. An example, okay? Let's actually start doing some math here soon. This is what reduced row echelon form is going to look like. Essentially, what I'm telling you is that this is the answer. If I can make my matrix look like that, we're done. Notice the placement of the zeros and ones. So it's a 1, 0, 0, 1. These question marks are going to be magical numbers that happen just from the process of us doing the 3 rules from above. So for example, looking at A, I need this matrix to look just like this matrix right here. You'll note that there's zeros and ones all right, but they're in the wrong positions. So what we will do with A is I would propose to you, let's take row 1, right? This is row 1, and this is row 2. So let's take row 1 and let's switch it with row 2. The double-sided arrow means we're going to switch. That means row 2 is going to become my new row 1. And row 1 is now going to become my new row 2.
That's all there is to it.
Note the placement of the 1, the placement of the 0, the placement of the 0, the placement of the 1, and then whatever numbers these are, whoop-de-doo, nobody cares, because A is done. We're done. That's it, Mr. Over? Yes, that's it. That may have gone too fast. You might want to pause and rewatch that because it was like, what the heck? I promise it'll get more complicated, but that is one of the 3 rules that we're going to use. So that was a fair problem. Let's try another one. B. So you'll notice again that I need to get this looking like a 1001 something something form. And I run into the same problem again. This 0 should be down here, this 1 should be up here, and so forth. So I'm going to do row 1, switch with row 2. That looks like, okay, row 2 right now is 105. And then my row 2 over here, my row 1 over here, is going to now become my row 2 over here. So I just switched the rows, not the columns. I switched the rows. I didn't do any math. I just switched the rows to put them in the right order so that it looks like this thing over here. I already have the 1 in the right spot. And I have the 0, and I have the 0, but darn, this 2 is supposed to be a 1. So obviously, switching is not the best thing for us here. Well, let's try something out. What if I took row 2? Now, what would I need to multiply? We're not adding or subtracting, we're multiplying. What would I need to multiply 2 by to get a 1 out of it? Hint, the reciprocal. If you don't know what that means, look it up. I'm going to multiply by the reciprocal of 2, not the 6. I don't care what happens to 6. I care what happens to 2. So I'm going to multiply by the reciprocal of 2, which is 1/2. I'm going to multiply that to an entire row 2, and I'm going to put it back in place of row 2. Notice that I'm using a one-sided arrow. So what does this mean? Let me show you some side work here. It means, let me copy down row 2 again. So that's 0, 2, 6. I'm not making my matrix yet. I'm just copying row 2 because that's what I said right here, row 2. And I'm going to multiply everybody in row 2 by 1/2. So this gets a 1/2, and this gets a 1/2, and this gets a 1/2. And for my mathematically challenged folks out there, let me help you out by putting this all over 1, if it helps. Now, people, work with me. 0 times 1/2, that's 0. But over here, the 2's cancel out, and I'm left with a 1 over 1, which is a 1. That's what we wanted. And then over here, I get 6 over 2. Well, that's going to give me a 3. So what I'm proposing to you is this. We took row 2, and I wrote it down again. And we're going to multiply everybody by 1/2 because it's a reciprocal of this 2 right here. And then when I do that, I get this answer. And I'm telling you now that this answer is our new row 2. So my new row 2 is what I got here, 0, 1, 3. But Mr. Over, what about row 1? Bro, I didn't say anything about row 1. That means row 1 is exactly the same as it was at the beginning of the problem. Note that what we have now is exactly in the right form. We have the 1, 0, 0, 1, just as we need in the official form of this answer. If you want to take a moment to kind of try part D without me, you'll note that the 1 is there, the 0 is there, and the 0 is there, but this 3 should be a 1. Think about what you would multiply by. Try to set this up. See how far you can go. Try it out. So if we take row 2 and multiply everybody by 1/3. But Mr. Over, last time we did 1/2. Yeah, because last time there was a 2. And the reciprocal of 2 is a 1/2. This time I have a 3. The reciprocal of 3 is 1/3. So if I multiply everybody in row 2 by 1/3, then I'm looking like this. 1/3, 1/3, 1/3. And then you get a 0. 3 over 3 is 1. And I have 6 over 3 is 2. So this would be my new row 2. We didn't do anything with row 1. And so row 1 just comes along for the ride. This is my answer to D. These 3 answers that we have so far, please note that these are all what we call reduced row echelon form. So when we express matrices in reduced row echelon form, it means we're going to make them look like this, where there's a 1, 0, 0, 1, and whatever these two numbers are at the end, as a result of using the 3 rules of the game.
That's all there is to it.
Okay, and then finally E. Interesting. So we do know that there is a 0 and a 0, but this should be a 1, and that should be a 1. So obviously we have a couple of things to do. Let's go ahead and first let's take care of this one right here. I'm going to do 1/5, row 1, and I'm going to put that back into row 1. So if I do 1/5 of that, here's row 1 originally. Here are the, 1/5. 1/5. Mr. Rover, how did you get 1/5? I need the reciprocal of that 5. So that's going to be 1/5. Oh, so you mean I just take the number and put it over 1? Careful, because that's not exactly true for the reciprocal. Okay. For example, if I give you a matrix and it was 3/4, 0, 2, 0, 1, 1, I would need to multiply row 1 by 4/3 and then put it back in the row 1. So if you're not comfortable with the idea of the reciprocal, which was hammered into you in algebra and in geometry, please, again, look it up. Do a quick search on it. But what I'm telling you is the reciprocal. If I multiply the reciprocal by the number, then I'm going to get a 1 essentially, and that's coming into play here a lot. So it's not just, oh, let me just go ahead and put this number over 1. You're actually flipping the number, if that helps. Okay, because right now I technically have, for this problem, I have a 5/1. So if I flip that, that's a 1/5. For those of you math people out there, we call the reciprocal sometimes a multiplicative inverse. Okay, so we come back to this problem where we 1/5 everybody in row 1, only row 1, and I get a 1, a 0, and a 2. That is my new row 1. Notice we're doing one step at a time. So that's 1, 0, 2. Row 2 is 0, 4, 8. Please don't do multiple steps for multiple rows and just be done. I know you can mentally do it, but the problem is sometimes bad habits creep in and you make mistakes. Let's just do one step at a time, rewrite the matrix, and do the next step as appropriate. So our next step is going to be, okay, we got the 1, 0, 0. Now this needs to become a 1. So we're going to do 1/4, row 2, and that's going to go back into row 2. Row 2 is 0, 4, 8. If I do 1/4 of everybody in row 2, I get 0, 1, and 2. That's my new row 2. So for this one, I'm going to write it over here. I get 0, 1, 2 is my new row 2. Row 1, of course, was what we had up here, 1, 0, 2. That is now in reduced row echelon form. So it is possible definitely to do multiple steps, to follow multiple rules to get to the result that we need. Summaries are important, folks. It is very important that you take the time to reflect and think and to write. How do you know what coefficient, the number in front, what coefficient to multiply a row by? Take some time to jot down your ideas.